a particle starts from rest, so in other words, v is equal to 0 when t equals 0, and travels in a straight line with acceleration cos pi t meters per second squared. We want to find the displacement of the particle after 2 seconds. Now, I'm not told anything about its starting point, so I'm going to assume the starting point is x equals 0. So we want the displacement of the particle after 2 seconds. So we know that A is cos pi t meters per second squared. Velocity then would be the integral of cos pi t dt. Now remember our pattern for trigonometric integration and differentiation. Cos is going to integrate to sine. We're going to need to use the reverse chain. And then we get some constant. V is 0 when t is 0. Sine of 0 is 0. Therefore, C1 equals 0. So V equals 0 when t equals 0 means C1 equals 0. Be very careful with that, because that's not always the case. It depends what the function is, as we'll see in a moment. Now, the displacement is, of course, the integral of velocity. So we're going to need to integrate sine pi t over pi, and the constant, of course, was 0. So that's going to be equal to, sine integrates to negative cos. So it's going to be negative cos pi t. We need to divide by a further pi because of the reverse chain. And then we'll add constant 2. Now I decided to take x is 0 when t was 0. So 0 is going to be negative 1 over pi squared, because the cosine of 0 is 1 plus c2, which means that c2 is going to be 1 over pi squared. Therefore, x is going to be 1 over pi squared, take away cos pi t divided by pi squared. Now, we want the distance travelled by the particle in the first 2 seconds. Well, we're taking, of course, x of 0 is 0, but we don't know exactly how the particle travels. Or at least we do, we just need to work it out. So we know from up here that v is sine pi t divided by pi. And so when is the velocity 0? So if we think about the sine graph, it's 0 at the beginning, and then it has various zeros as we go through. So the first one is at 0, then we have one at pi, then we have one at 2 pi. Given that this is sine pi t, this one's going to correspond to t equals 1. This one's going to correspond to t equals 2. So it's going to change direction, potentially, when t is 1. If the velocity is 0, let's say it's travelled this way, and then the velocity is 0 here, it could start up again in the same direction, but it could come back. So we actually need to investigate that. Well, what I can do is work out x of 1, and then I can work out x of 2. So here's our expression for x. The cosine of pi is negative 1. So when t is 1, that's going to become 1 over pi squared. Take away negative 1 over pi squared. So this will be 2 over pi squared. When t is 2, the cosine of 2 pi is 1. So that will become 1 over pi squared. Take away 1 over pi squared, so it's back at the beginning. So what this particle does is it travels out a distance of 2 over pi squared and then travels back a distance 2 over pi squared. So in other words, the distance travelled is 4 over pi squared. Now there is a way on the calculator of doing this without having to do all of the analysis that we did down here. And once again, it involves the modulus function that we've met before. It also involves the idea of total change from rate of change. What we're actually going to do is the integral from 0 to 2 of the modulus of the velocity. And that should give us the total distance travelled. So let's get our calculator back. This is a very useful trick, both in the methods exam and in specialist. So 0 to 2, and we've got the modulus function, and I've got sine of pi, let's just call it x, it's easily accessible. And I need to close the bracket on that. And of course that is over pi, and with respect to x. And there it is, 4 over pi squared, the same as what we got over here.